In this video, we're going to talk about the domain of a composite function. Remember, a composite function is a function where you have other functions buried within other functions. So, for example, if you look at this one here, the function here is a positive root of this thing here. But then you can break this up here, because you can say that this here is one function, and then when you bury this function into here, then you in effect will get this function here. Okay, so if you this here is a composite function because it has a function buried within another function, and in this video we're going to talk about the domain of a composite function. So remember the domain. There are lots of ways of imagining a function. So let's look at this one here. If you look at this one here, this function here, it's okay if you put the number, let's say 1 into here. So 1 divided by 1, it will spit out the number 1. But if you put in 0, then the machine here breaks down. So you can imagine this as being a machine here. So this is 1 over x here, and your domain is all the numbers which you can put into the machine without it breaking down. So you can put all these numbers into this machine, and it will spit out different numbers. But you see, the number 0 for this machine, it breaks down if you put the number 0 into here. So the number 0 is not in the domain. Well, anyway, looking at this composite function here, to find out the domain of this complicated function, you well, first look at this function here, and then look at this function here. Well, the domain for this function here is, well, it could be anything. So anything on the real number line where x cannot be 0. Okay, so if you look at the domain for this function here, it will look something like this. Let's say this is your number line: 0, 1, 1, 2, 3, and so on. -1, -2, and -3, and so on. Now the domain for this function here could be anything on this line here. That's what it means by x belonging to the real number line. This R here is anything on this line here. Okay, but it cannot be 0. This here, but basically, if you were to draw hang on. So the domain for this function here. The domain for this function here could be anything on this line, but not 0. So you would probably represent it by this this line here. Anything on that real number line, but not 0. So we normally have, well, the way we represent it from our sections on inequalities. It would be anything on here, and then you would have a circle here, and the way you would write it would be something like this. Okay, just imagine it like this: but not including the 0, not the 0. Okay, now if you look at the domain for this function here, remember your square root of x, graph will look like this. But because we need to turn into a function, we're gonna ignore the negative side. Okay, so that's why we've got this positive root here. We are only concerned about the positive root. Okay, so bear with me on this. Hang on. So the domain for this function here, well, the domain for this function here could be anything but not a negative. Okay, so if you look at the number line for this one here, let's say 0 here, 1, 2, 3, and then here you've got -1, -2, -3. You see, you cannot have a square. If you choose, let's say, -4. Let's say if you choose -4, what's the square root of -4? You can't. Well, at the moment, you can't really do it. Now, you got to think of a number. When you times by itself, it gives you a -4. If you try -2, 2 times 2 is 4, but then you've got negative and a negative. That gives you a positive. It doesn't give you a -4. So anything on the negative side here, it won't work. It would just break down. So so the domain for this function here would be anything on the positive side, but you can't have 0 because the square root of 0 is 0, because 0 times 0 does give you 0. So you can't have 0. So the domain for this function here could be represented as this. It can include the 0, and it can be anything on the positive side. Okay. So if you if you look at this function here, basically you've got this thing here. You've got a machine here. You've got a machine here. Let's say this machine here. But within this machine here, you've got another machine here where you have a square root. So 1 over x. You see, when looking at this domain here, if the inner machine breaks down, then the outer machine also breaks down. And then if something breaks down on the outer machine, then you can say that the whole machine breaks down. So when you look at the domain for this function here, you've got to take care of two machines, the inner one and the outer one. So if you look at the domain for this one here, it's given by this line here, but anything here, but not the 0. If you look at this function here, the domain for this function here, it can be anything. It can include the 0 and anything above 0. So basically, you've got to look for some. Well, here you've got to look for the intersection, if you like, of the two. So looking at this here, you've got to look at this, and look at this here. So you can think of it as the intersection of the two domains. So for example, you see, if you choose something in the negative realm here, then this machine here breaks down. This here breaks down. So this here breaks down. If you choose something in the negative realm, this thing here breaks down. If you choose the number 0, then basically you've got to choose something that will work for both machines. You see, anything that will work for both machines, you can't have 0, because if you choose 0, this machine breaks down here. So basically, the domain that will work for both machines would be x above, strictly above 0. You see, if you choose something in the negative realm, this one here breaks down. If you choose the number 0 itself, then this machine breaks down. So you've got to choose a domain where it will work for both machines, and the only it will only be when x is above 0. So the domain for this, you could say x belonging to the real number line, comma, and then x being above 0. Okay, or maybe you don't actually need this. People can assume that. So you can just say the domain for this whole function here would be for x being greater than 0, strictly greater than 0. It cannot be 0. Okay, so yeah, okay.